Let's take a look at this CAMG Simulink interface using this example. We have on the screen, we have a model that you see here has been already drawn. This one is the velocity rotation of this mass. This one is of the other. We started building the bond graph that way, and then we attach the elements that see those velocities, which are these three. In the other case, these other three. And then later on we put this in, you create the relative velocity between this and that, and we have the other two elements. This is following the procedure that we have studied in several prior lectures, so we're not going to explain that procedure right now, but if anybody wants to, you could refer to the other lectures that have that procedure. But right now, let's concentrate on, we have this bond graph model. That's what we have. So what we need to do is we need to get the bond graph model into the CAMG software, and that's exactly what we're going to do right now. You see, there it is, and we go in here, and of course we would like to do a new file here. See, this is new, and then we're ready to begin building this. But I think I need to have my bond graph visible in here, so that I can actually see what I'm doing, and this is exactly what is happening right now. So if you have in here, you have the SC. We'll start putting it in here, and then we say a 1, and then you put that bond graph model. What we are doing in entering the bond graph model on the screen, we are just, in this case, drawing it. We could have done the bond graph model directly into CAMG, and I believe that's something that we should try to do, so that you gain a lot of time, and then you won't have to do what I am doing right now, but rather you would have created the bond graph model ready for simulation. And I think that is a good practice. In other words, go directly from the system into the CAMG software, and do all your editing of the bond graph over there. And once we have in there, we are ready to go. So this is here, and then we have, I'll finish in just a moment. We have this eye over here. What's happening, as you can see also, is that we are letting the program do the numbering for us. And not only that, the causal marks are also being assigned by this one. Just a little bit of a, making this pretty. You could move this one a little farther down to straighten it out, and everything looks cool. So so that we have a record of this on the left hand side, what I would suggest is that we have a we take a picture of this bond graph and put it on my notes in here. In fact, we're gonna carry them and put it over here so that you can see right there. All right, and we can work with it now. So now we can go back to where I was using CAMG, and then right here. So I need to go to the interface now, and in this case I am going to choose the Simulink interface. And what is going to happen is CAMG gives you this message. It says, you are about to produce this CAMG ini file, which means the initialization file, where the matrices A, B, C, and D take place, you're gonna have the CAMG num file, which is a file where you would initialize the transfer functions, and then you have this camgtf.mdl, which is the state space form. No, excuse me, the transfer function form in Simulink, and you have the camgsst.mdl, which is the state space form. So, having said that, let's have the interface proceed between CAMG and Simulink. And what it does is it gives you a couple of files that already have block diagrams on it, and also it gives you a couple of files that enable you to initialize the values. So because we are doing a simulation where we want outputs, we are not, although we are working in symbolic form, but by initializing and putting initial values into those, we're working with numbers. Essentially, in Simulink, we're working with numbers. Okay, I think, yeah, there you go. So the Simulink interface is going to give you these two, basically three things. It's going to give you this CAMG ini, and then you have this CAMG num. So first of all, if we work with the state space form, do you see? And here you have to initialize those. Anything in the CAMG files that are produced that have question marks, anything that has question marks, you need to enter a number. So in here, let me just make this a little bigger so we're able to read well. And then in here, we can see, okay? So this is the CAMG num file. Here's where the parameters need to be initialized. And but in here, you see there are all the matrix equations on the Cauchy form and the outputs as well. So what we need to do in this particular case is make sure that we know what output that we want. In this case, let's define the outputs. What we have done in here, we chose the Simulink interface, produce the matrices, understand clearly the state variables and the inputs. And what is the output in here? So we need to say in this particular case, let's just choose one, okay? I'm going to do it with one so that we don't get too complicated expressions. So in this case, let's say, for the sake of example, we could given this, so what's the angular velocity of this mass? So you tell me from this graph, what variable is that? What's the output? The angular velocity of this mass. Can you see it? Huh? Yeah. So this is F9 is my output. So we need to find a transfer function that says F9 of S divided by the input, which is SE1 of S. This is the transfer function that we want. So in order to do that, we are going to go into the file and we say, where is F9? Well, first of all, we gotta give it some numbers. And in this case, I will just give it some nominal numbers in here, like the masses would be 2 and 4 maybe, and then the R, let's put this as a 1 in here. These are numbers just so that I can get something going here. These arbitrary numbers, but hopefully some that make sense 40, and this one the same maybe, or 1/5, something like that. And then we have this arc, this, let's say like a 5. Okay, we need to look for the outputs. Where is it? Where is F9? Yeah, there is F9. And so if we do this, we activate those lines and we define this as our output that we want. We put this at our first row of the C and D matrices, and we're going to close this, and then I am going to say run, but we need to also see the MATLAB window, so that, okay, there we go. I guess we're going to put it down a little bit so that we can see both of those at once. I think I am getting this one right here. See, we have the file in here. So let's say run and see what happens. See what happened now? In MATLAB, you got the you got this the A and B and C and D matrices. Now I noticed something that you need to be aware. The matrix C looks like the identity matrix, right, with diagonals on the first one. The reason is that this file, this CAMG any file, by default gives you all the state variables as outputs. But in our case, we don't want that. We want F9. So you need to make a little modification on this file to get that one to work, and I want to show you what that is. Do you see here what it says? Is defining the C and the D matrices so that these are the state variables. And if you suppress this, you are back to where the way we know this file with the CAMGSYM file, it will produce only one output. So let's just run this. See right here, and then you will have this, the state variables, the matrix, the B matrix, the C, the D matrix here, yeah. But you see what has happened here is it has initialized everything. See in here you say A will give you that matrix in here. See what that command pretty did when it was symbolic? It looked nice and organized in, on the screen. And this is the numeric matrix, not a symbolic matrix. This is B would look like that. Then you have the matrix C, of course, in this only one, one row. And then the D matrix, which is this one. Okay. Now, you know that you have the A, B, C, and D matrices all in there. What you need to know right now is that because of that, this block diagram is already active and already, you may say, energized. It's initialized. It's the CAMG Simulink interface. So if you have a step input, which is what I have in here, how many inputs do we have in this case? We have only one, right? So why don't we go in there? It says 2. By default, this is just like a sample in here. And it has only 1 in here. And how many outputs do we have? We also have only 1 output. So this is in here. And the output is what? It's gonna be the F9. So there it is. So if I go in here and I say run, what I'm gonna see here is F9. See if I click in here. In fact, that's what happened. In here you do it this way. And we have actually used the state space form to get the step input, a step response of the system. This is how you should do yours. In other words, you run the CAMG Simulink interface, and once you initialize the matrices and you define the output, then you can do it this way. But you see in here, you have the ability to use the transfer function also. But this one, the CAMG ini file, is only designed for the state space form. If you want to use the transfer function, which already got produced, let's just go to the other file, which is over here. It's the same file, but this is oriented towards the transfer function. So what we need to do is, I pasted the same numbers. I need to do the very same thing. Where is F9? It's right here. It's a different file, although it has the same equations. We're doing a different thing, so it's not like you can simulate both at the same time, but rather they are independent from each other. So in here I just define F9 as my output. I want to make sure also that I'm not getting the state variables. Yeah, here, see. This one by default will give you the state variables, but in our case we do not want that. We want the, let's see, we want the the output that we want. So there we go. We have. Let's run it. Okay. So in here, I'm just gonna leave that one by itself in here, and I am going to run this file like this. So I have to look at the MATLAB one right here, and also the MATLAB to see, in fact, what it's going to do. Okay, excuse me. I don't want to make a mistake in here. I think I might have suppressed. I did suppress one line too many. Where is it? Right here.
It's line 150.
150? Thank you. Yeah, this guy. Let's just, we need the identity matrix. There you go. See what happens now if you make a run that way. You have the matrix A, B, C, and D, but immediately the computer went ahead and actually did the step and impulse response right there. And in fact, this is exactly the same as this. See the one on the right hand side. These are the this was done with the state space form, but this one is done with the transfer function, and that's how you do it, using the transfer function.